So this is the second part of limiting and excess reactants. So here we have an actual chemical equation. And in the previous one, we were talking about the Powerpuff Girls. And we were talking about how they need sugar, spice, and everything nice to create the Powerpuff Girls. But here we have carbon dioxide reacting with water to form glucose and releasing oxygen. So this would just be the production of some type of simple sugar and releasing oxygen. This would be something that happens in plants, all that kind of good stuff. So now let's say we want to feed our plants. And this is what we want to feed our plants, that glucose. Super, super good for them. Very, very good food. All that good stuff. And we take a look at how much CO2 and how much water we have. And let's go ahead and make it nice and even. Let's say we have 100 grams of CO2 and 100 grams of water. And we encounter those two questions once again. What's the quantity of glucose we can make? So how much glucose can we make? And what's stopping us from making more? So those are the two big questions. So for this, what you're going to do, number one, convert to a common unit and compound. So for this one, we're trying to figure out how much glucose is made. And so we're going to go ahead and convert both of these, we're going to say, to moles of glucose. So we'll start with CO2. Grams of CO2 up top means it's going to the bottom. We know that in order to switch compounds, we have to become the mole. And we know 1 mole is equal to molar mass, and the molar mass of CO2 is 44.01 grams. You can figure that out by looking at the periodic table, adding up everything, 1 carbon, 2 oxygens. Moles of CO2 up top means it's going to the bottom. We'll put moles of glucose up top. Keep in mind that this was that special step that we talked about in stoichiometry, that mole to mole. So anytime you see mole over mole, you look to the equation to get those numbers. So next to CO2, we see the number 6. And next to glucose, we see the number 1. So plug it in to get our answer. So multiply everything on the top, multiply everything on the bottom, divide the 2. So I'm going to do 100 times 1 times 1. Divided by, open parentheses for the bottom, 44.01 times 6, close parentheses, so that's the bottom. Hit enter, and that's the whole thing. We'll go ahead and round it to 3 decimal places out, so to the 1/1000, so 0.379. Moles of C6H12O6. So now we'll do the same thing for water. So grams of water up top means it goes to the bottom. We're going to moles of water up top. For grams to moles, you use molar mass. So 1 mole is equal to 18.02 grams. So again, utilize the periodic table to get that molar mass. We have moles of water up top. That means it's going to the bottom. And once again, we're trying to get to moles of C6H12O6 glucose. So there's that special step again. We see mole over mole, which means we're going to look to the balanced equation. Next to glucose is 1. Next to moles of water is 6. Once again, plug it all in. 100 times 1 times 1 divided by 18.02 times 6. And you get, again, let's go to the 1/1000, 0.925. So now we have these two numbers for the moles of glucose. And while that's good to know, the way to know which one is going to be actually produced is always going to be the smaller one. So the smaller number is actually produced. And it's the limiting reactant. So between these two, we see one is significantly smaller. So a couple questions you should be able to ask, or be able to answer, is how much glucose is made? So actually made is 0.379 mole of C6H12O6. Sorry, I ran out of space there. What is the limiting reactant? And for that, you see what it came from. So we go all the way back to the beginning, and we see that this was based on grams of CO2. So that means CO2 was the limiting reactant. The other question is, which one is the excess reactant? So which one is going to be left over after we make as much as we can? And so that would be the other one. So whichever one we didn't actually make, we go all the way to the beginning, and we see the excess reactant was water. So the other part with this that you're going to have to do is figure out how much excess is left over. So this is going to be kind of like that level 4 question. How much excess is left over after the reaction happens? So keep in mind, once this reaction comes to completion and it's completely done as much as it can and as much glucose is made as can possibly be made, we only made 0.379 moles of glucose. So for determining the amount of excess, you start with how much was actually made. So you go from 0.379 moles of C6H12O6, and you're going to convert it to the unit and compound of your excess reactant. So we see our excess reactant is water, and water was originally given to us in grams, which means we're going to convert it to grams of water. So it's the same unit as your excess reactant and the same compound as your excess reactant. So that's how we got grams of water. So we start with our given. We line it up. If we have moles of glucose up top, it goes to the bottom. Got to go to moles of water so we can get to grams. If we see mole over mole, we look to the equation. So it's a 1 to 6. Moles of water goes top to bottom. Again, we're trying to get to grams of water. So again, we utilize molar mass, which is 1 mole is equal to 18.02 grams. We'll go ahead and plug that in. So 0.379 times 6 times 18.02. We get 40.98 grams of water. So this is not the amount of excess left over. What this is the amount of water used. So it's how much water was used in the creation of that 0.379 moles of glucose. So now for this question, it's not asking how much water or how much of that excess reactant was used, it's how much of it is left over after the reaction goes to completion. So to figure out what's left over, you just find the difference. So we started with 100 grams of water. We used, in the process of creating that amount of glucose, 40.98. So we'll subtract the 2 to get the grams of water left over. So we plug it in, 100 minus 40.98, and we get 59.02 grams of water left over. So again, we took what we actually made, converted it to our excess. What we started with for our excess, we took away what we used, and that's how we get what we're left over with.